Auzu billahi minash shaitanir rajim. Bismillahir rahmanir rahim. Dear student, Assalamu alaikum. In the last lecture, we discussed different types of chemical bonding. In today's lecture, we discuss the theories of bonding. The first theory of bonding, which is included in your syllabus, is the valence shell electron pair repulsion theory. So, in today's lecture, we will discuss the valence shell electron pair repulsion theory. Outlines of today's lecture include introduction to valence shell electron pair repulsion theory, and we will discuss the postulate and how this theory explain the shape of different types of molecules. And at the end, we will discuss the limitation of the valence shell electron pair repulsion theory. So, what is valence shell electron pair repulsion theory? The valence shell electron pair repulsion theory, which is shortly known as VSEPR, whisper, is a model to predict the molecular geometry based on the numbers of valence shell electron bond pair and lone pair among the atom in a molecule or ion. According to this theory, the bonded pairs of electron and the lone pair of electron arrange themselves in a way to minimize the repulsion. So they are at maximum distance to minimize the repulsion between the lone pair and the bond pair. And when they repel each other and when they arrange themselves at a maximum distance, it gives a specific geometry to a molecule. So this valence shell electron repulsion theory is generally used to explain the geometry of a molecule. This model assumes that electron pair will arrange themselves to minimize repulsion from each other from one another. The theory was first presented by Sedgwick and Powell in 1940. The valence electron pair repulsion theory, abbreviated as VSEPR theory, is based on the principle that there is a repulsion between the pairs of valence electron in all atoms and molecules, and the atoms will always tend to arrange themselves in a manner in which this electron pair repulsion is minimized. So the lone pair of electron and the bonded pair of electrons arrange themselves in such a way that the repulsion between these valence electrons are minimum. This arrangement of atoms determines the geometry of the resulting molecule when they are far away from each other, and when the repulsion is minimized, it gives a specific geometry to the given molecule. For example, we can see over here many examples. First example is the carbon dioxide molecule. In carbon dioxide molecule, we can see that the carbon is doubly bonded with oxygen atom, and they are at maximum distance. And at maximum distance, they are at 180 angle. So when they are in 180 angle, they are at maximum distance, and the repulsion is minimum, and it gives a linear geometry to the carbon dioxide molecule. Similarly, the second example is sulfur dioxide molecule. The sulfur is doubly bonded to the oxygen atom, while the sulfur contains the lone pair of electron also. So the repulsion between the lone pair and the bond pair is maximum is compared or more than the bonded pair of electron. When they arrange themselves in such a way that the repulsion is minimized, it gives an angular structure to the sulfur dioxide molecule. Similarly, we can see the molecules of water, and water molecule, we can see that the oxygen is singly bonded to two hydrogen atom with 109 angle, and the two lone pair of electron which is present on the oxygen atom, there is maximum repulsion, and the bonded pair have less repulsion as compared to the lone pair of electron. The water molecule have also a band structure. So in these molecule, we can see that the bonded pair of electron and the lone pair of electron arrange themselves in such a way that the repulsion between the bonded pair of electron and the lone pair of electron is minimum. So, what are the main postulate of the valence shell electron pair repulsion theory? So, we will discuss the different postulate one by one. The first postulate of valence shell electron pair repulsion theory is that in polyatomic molecule, one of the constituent atom is identified is the central atom to which all other atoms belonging to the molecules are linked. For example, in the last slide, we see the carbon dioxide molecule. The carbon is the main constituent, while the oxygen atom are belonging to that carbon atom. Here we can see some other examples. Uh, for example, we can see over here, just 1 minute. We can see over some example, for example, boron trifluoride. In this boron trifluoride, boron is the main constituent, while the fluorine atom is around the boron atom. The first postulate is that one of the atom is considered as the central atom, while others are belonging to these molecule. We can see the phosphorus pentachloride molecule. The phosphorus is the central atom, while the chlorine atom belonging to linked to the phosphorus, the chlorine atom linked to the phosphorus atom. The second postulate is that the total numbers of valence shell electron pair decide the shape of the molecule. If there are two bonded pair of electrons, they are at maximum distance and they have linear structure, as we can see in the example of carbon dioxide molecule. The third postulate of valence shell electron pair repulsion theory is that the strength of the repulsion is strongest in two lone pair and weakest in the two bond pair. So if we consider the strength of repulsion between the lone pair and the bond pair, then the lone pair repulsion is maximum as compared to bond pair, and the bond pair and lone pair is intermediate repulsion. Here we can see the example of carbon dioxide molecule. The carbon dioxide molecule have two bonded pair of electron on each side as the carbon form double bond with oxygen. So they are at maximum distance and they have minimum repulsion between the bonded molecules. So it decides the geometry of the carbon dioxide molecule that the carbon dioxide molecule will be linear. Similarly, we can see the structure of sulfur dioxide. Sulfur dioxide have a bent geometry because the repulsion between the bonded pair of electron and the lone pair of electron is intermediate, while the while the bonded pair of electron have minimum repulsion as compared to the lone pair and bond pair of electron. Therefore, the structure of sulfur dioxide is a bent structure. Similarly, water molecule, we can see that the bonded pair of electron and the lone pair of electron have repulsion, the lone pair of electron have repulsion, and the bond pair electron have repulsion. So it have also a bent shape molecule. So the valence shell electron pair repulsion theory explain actually the geometry of molecule based on the valence shell electron pair. If there are bonded electron and lone pair of electron, they arrange themselves in such a way that the repulsion is minimized. The fourth postulate of valence shell electron pair repulsion theory is that when the central atom surrounded by both lone pair and bond pair of electron, the molecule would tend to have a distorted shape. As we can see in the molecules of sulfur dioxide and water molecule, the structure is distorted or bent shape. For example, here is another example of uh, uh, here is another example of distorted shape of molecule boron trichloride. In this case, the boron is at center and chlorine are surrounded by the boron atom, and this have a trigonal planar structure. And in this case, when they are at 180 angle at a trigonal planar structure, then the bonded pair of electron have minimum repulsion. Similarly, we can see the structure of ammonia. In ammonia, there is bonded pair of electron and one lone pair of electron. So there are two types of repulsion. The bonded pair of electron repel each other, and the bonded pair and lone pair electron repel with each other. Therefore, as the lone pair and bond pair repel each other more than bond pair, therefore the structure of the geometry of ammonia molecule is trigonal pyramidal. Here we can see the T-shaped structure of boron trifluoride. In this case, bromine trifluoride, bromine have two lone pair of electron, and this molecule have three bonded pair of electron. So based on This electron pair repulsion, bonded electron pair repulsion, and lone pair of electron pair repulsion, the bromine trifluoride molecule have T shape. So the valence and electron pair repulsion theory actually explain the structure or geometry of molecule. Similarly, we can see the bromine trifluoride structure that the repulsion between lone pair and bond pair make a T-shaped molecule. The order of repulsion between electron pair is follow. The lone pair have greater repulsion as compared to lone pair and bond pair, and the lone pair and bond pair have greater repulsion as compared to bond pair and bond pair. The next postulate of Valence-Shell electron pair repulsion theory is that if electron pair around the central atoms are closer to each other, they will repel each other. This results in an increase in the energy of molecule. As we can see over here, that the water molecule have band shape because the energy is increased by the repulsion of lone pair of electron and bond and lone pair of electron. If the electron pairs lie far from each other, the repulsion between them will be less than, and eventually the energy of the molecule will be low. For example, we can see the structure of methane molecule. In this case, the repulsion is less as compared to the lone pair of electron, and therefore this molecule have lower energy. The valence shell can be thought of as a sphere wherein the electron pairs are localized on the surface in such a way that the distance between them is maximized. So the bonded pair of electron and lone pair of electron will arrange themselves in such a way that the repulsion is minimized. The eighth postulate of valence and electron pair repulsion theory is that the electron pairs have a tendency to orient themselves in a way that minimize the electron repulsion between them and maximize the distance between them. As we can see, the structure of carbon dioxide molecule that the maximum is they are at maximum distance and therefore the repulsion is minimum. Similarly, in case of methane molecule and ammonia molecule, they arrange themselves in such a way that the bonded electron and lone pair of electron are at maximum distance and they have minimum repulsion. So the valence shell electron pair theory can be applied to each resonance structure of a molecule, and the valence shell electron pair repulsion theory generally explains the geometry of molecule based on the valence shell electron present. The bonded electron and the lone pair of electron generally decide the shape of molecule. So in today's lecture, we discuss the various postulates of valence shell electron pair repulsion theory. In next class, we will discuss the geometry of molecule based on the valence shell electron pair repulsion theory. Thank you.